Hi, my name is Bethany Lazarus, and this is our video on our nutrition tracking database by Bethany Lazarus and Abner Orozco. So these are our project goals and description. Our project goal was to find a way to help a user track specific food items for breakfast, lunch, and dinner, while also tracking the calories consumed for certain food items for each of the meals. Also, we're helping track the weight of the user on certain days and looking at the difference from the beginning and end of the tracking time, which is 20 consecutive days. So this is just a little database description. So our tables are food item, calories, breakfast, lunch, dinner, and weight. Oh, and that should also include the date. Each table has a primary key. Some of them also have foreign keys, and we use these to pull out queries and just help the user be able to exceptionally track their weight and food items and calories. So these are the ER diagram and relations. As you can see, the ER diagram represents each of the tables and the relationships, or this is in these case, entities right now with their attributes. And then these are the relations from the ER diagram. You can see each of the tables with their attributes, or what will now be columns in the database. So here are our queries. And query 1, this is just a basic query. We're doing select all from the table food item, ordering by food ID. This query just selects all of the columns in food item and then orders them in their food ID in ascending order, actually. And here is the example of the code. As you can see on this side, here's our output. And query number 2, we are selecting the count for the column numcal and the column food ID from the table calories. And this query just selects the food ID and counts the number of calories from the calories table. And as we can see, count of the numcal, 3 for number 9, 2 for 10, the same number of calories is what we're looking at. So if number 9 had 250, then there was another one that also had 250, and another one as well. So query number 3, we just did select date ID and decal from the table dinner, where decal is greater than or equal to 2000, grouped by the length of the date ID, and put date ID in descending order. So this query just selects the date ID and the decal columns from the dinner table. After it makes the selection, it gets all the values that are greater than or equal to 2000 in the decal column, and then it sorts it by date ID in descending order. So here is the example of that. As we can see, the descending order. Then we have our date ID and decal. So query number 4, we did select weight ID, WNUM, date ID from the table weight, where WNUM is less than, and then we did a nested query, select the average WNUM from weight. So first we have to meet this condition, and then we meet this condition, or display this query. So it first selects the, first it gets the average of the WNUM and is displayed, and then it takes this and executes this query. And that is our example. So for query number 5, we did select food ID, fname, lcal from food item, and we did a join condition with food item and the table lunch, where the food ID primary key and foreign key are joined together. So this query selects the food ID, fname, and lcal from the food item and lunch tables, and then the output is these columns with the correct values using the join condition with the values of food ID, fname, and lcal. So here's an example of that. As you can see, food ID, fname, lcal, and all of the values. And that is it for my part. See Abner's video for the rest.